same thing for polynomial evaluation also. So I think the last topic in this unit is going to be project analysis. So we are going to analyze the whatever we have studied so far using some small project. So it contains the data. So the variable MPG, see here MPG, HP, and WD. We have three variables in the workspace. They contains NaN values. So remove those rows from all the three data vectors. So you know whenever you have an NaN value, you cannot process with that easily, right? So I am going to remove all the NaN values. So this we have seen in the last class. You see here NaN of IDX equal to is missing of MPG. I am finding where this MPG is having NaN. So all those values of that index is returned in an IDX, and I am making all these things empty. That is what is done here. So I am removing those. I am making as empty means I am removing those rows. So now you see the size has reduced from 50 cross 1. It's reduced from 50 cross 1. Okay. Now you see create a variable econ that can contain the fuel literacy liters per kilometer rather than miles per gallon. I am going to convert the data using the conversion formula. So if I want to calculate the economy in liters per kilometer, I'll be dividing it by dividing 235.1214583 by MPG. Okay. So I'm going to calculate the economy in liters per kilometer, but actually it is given in miles per gallon. The conversion is given here. So economy equal to 235.214583 divided by MPG. And now I am putting, they are asking us to put all the numerical data into the array called num data. The economy is calculated and everything is put into num data. So if you see the workspace, you have something called as num data, and num data will have WT, HP, and economy. It has three columns. Create a matrix of scatter plots in the variables num data. Also calculate the corresponding correlation coefficient and store it. So this project will summarize everything, whatever your the plot matrix of num data. If you do, you will get a perfect plot. And I'm going to find the correlation coefficient. So correlation coefficient lies between -1 to +1. You will get a good plot. See here, you get a 3 by, I think you get a 3 by 3 3 by 3 plot. Yes, see here. So the diagonal elements are going to be the histogram, and this is going to be scatter plot for the individual things. And this is the correlation coefficient. So 1, 0.9, 0.9, 0.9, 1.83, 0.9, 0.83, 1. So everything is close to 1, right? So it indicates a perfect correlation data. The data is going to be